Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 3, Translating Lines. Remember that translating also means to shift, but we will use the word translating from now on. I was a little sloppy earlier in the last two videos and kept saying shift, 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 but it's actually a translation. Alright, so classwork exercise 1. It says to draw a line passing through point P that is parallel to line L. Well, in this diagram here, they aren't showing the letter L here, so let's just label it. This is line L, here's point P. So it says to draw a parallel line through P that's parallel to L. So take a moment to do that. And then it also says draw a second line passing through point P that is parallel to line L that is distinct, i.e. different from the first one. What do you notice? So do that, and then I'll take a look at this. Okay, so now that we've had some time to do this, I will bring my ruler down, and I just want to show you that to draw a line parallel, first of all, we have to show that, okay, that is right on that line. So a parallel line is a line that will, two parallel lines are lines that will never intersect. They go on in both directions forever, and they will never cross paths. In order for them to be parallel, they have to have something that's similar that we haven't discussed yet. So there is a line going through the point P that is parallel to L. Now it says to draw another distinct line, meaning a different line through P that is parallel to L, and the only way I can do that is to draw the same exact thing over again. But as you can see, it's right on top of the other, so basically it can't be done. Alright, so if I just toss that aside, and we will not use that anymore, so we notice that you can only draw one distinct line through a point parallel to a second line. Okay, now it says translate line L along the vector AB. What do you notice about L and its image, L prime? Okay, so what they're saying is we have this line, L, and then they put a vector here starting at A. My initial point is A, my terminal point is B. So what they're saying is I want to draw a line, translate line L along vector AB. What do you notice about L? So I'm just going to copy it. I can't move what's just already there on the paper, but if I create this line, this green line on top, okay, and I move that around, then you see that that is line L. So what they're saying is move line L, and here's my initial point, drag it. So I'm going to choose it, and I'm going to drag it until I get to B, which is right here. So now that line L is over here, but as you notice, there are arrows at both ends, which means they go on forever and ever and ever. So L and its image, L prime, which is the green one, is the same thing. It's a line sitting on top of another line. So we can now say that L and L prime coincide, okay, or L is equivalent to L prime, okay, they're the same thing. Shifting a line that goes on forever to the right or to the left, nothing changes. You wouldn't even be able to see the difference unless it was different colors in different locations. So a shift of a line is just a movement of the arrows, if you will, but they go on forever in both directions, so it's just a line on top of a line, or they're equivalent. Okay, number 3. Line L is parallel to the vector AB. Translate the line L along vector AB. What do you notice about L and its image, L prime? Okay, so if I am going to move this line segment the distance from A to B, I need to do what I did in a prior video, Okay, so now I put a green arrow or a green vector over the red vector. So if I move the initial end A of the green vector to the terminal end of B on the red vector, that is a distance from A to B in the direction to the right. So if I move this, okay, so what I want to do is group these. Okay, group this along with this. Okay, so now if I move this purple line L from A until I get the distance to B in the same direction, then you see that line L has now moved from here over here to here, but it's still on that same line that goes on forever and ever. So again, they coincide, and therefore L is equal to L prime, where this is my L prime now. Purple. So it's just laying on top of the original, and it's just shifted, but they're both going on forever and ever, so it's the same line. Okay, number 4 says translate line L, and I've copied it in green along the vector AB, so I'm going to shift it from initial point A up to terminal point B, the distance from A to B in the direction of the arrows. And what do I notice about L and its image, L prime? So if I grab L and I move it up so that I move A to B, which is right here, I have now moved the blue vector, the length of the red vector, so I've moved it from A to B. So in essence, I have moved line L up the distance from A to B in that direction. And it says, now what do you notice about L and its image, L prime? And I can say that L is parallel to L prime. And these double lines here mean parallel. In other words, L prime will not ever cross L. It can go on forever and ever in both directions. So does L, but they will never intersect anywhere. Okay? All right, number 5. Line L has been translated along the vector AB. So it was here, and it was shifted down to the terminal end B, the length of this vector, and now L prime is here. What do you know about lines L and L prime? And it is just like the last example, and the answer to that is L is parallel to L prime. Okay, so number 6 says to translate L1, line L1, the red one, and L2, the blue one, along vector DE, the green vector I drew. Label the images of the lines. If line L1 and L2 are parallel, what do you know about their translated images? So I'm going to choose the red one first, and I'll group it with my vector so that they both move in the same direction, in the same distance. When I move one, they both move. Okay, so if I am going to move this green vector, it tells me to move, I'm moving actually the red line from D to E in that direction and that distance. So if I grab that and I move it in that direction, I end up right here. And now I'm going to label that L sub 1 prime, or a translation of L sub 1. Okay, so there's my L1, and the red is L1 prime. Now I'm going to do the same with L2. First I need to ungroup these. Okay, I'm going to move this vector now back to its initial location, where it's a copy of DE vector, and I'm going to click on the green, and now I'm going to combine the two so that they move together, and I'm going to move the blue and the green vector in the same direction, same distance. So if I start at initial point D and move it along this line, this vector, until I get to the terminal end E, then that's where it ends up right there. Now I'm going to label the new line L sub 2 prime, or I could call it L sub 2 prime, or I could call it T of L sub 2, the translation of L2. Okay, so then it asks us a question. It says, if L1 and L2 are parallel, that's the black ones that were given, if they're parallel, what do I know about their translated images? So if I just shift a line from its original location in a certain direction, a certain distance, then what do I know about the copy is what they're asking. What do I know about the image with respect to the pre-image? And I would say, since L1 is parallel to L2, then the copies, which I will call L sub 1 prime, will be parallel to L sub 2 prime. Okay? If these two are parallel, then their images will also be parallel when they're translated. Okay. Lesson summary says, two lines in the plane are parallel if they do not intersect. Translations map parallel lines to parallel lines, and given a line L and a point P not lying on L, there is at most one line that passes through P and is parallel to L. So those are the three summaries to this lesson, and that is the end of lesson 3. Go do your problem set.